After high school. This tutorial is going to cover contingency tables and categorical variables. Specifically, when we have multiple categorical variables, how do we look at it? How do we take care of marginal distributions? Maybe even talk a little bit about conditional probability or conditional distributions. Situation is that you have 3 graduating classes and you have a survey that's asked each graduating class, what was your activity after high school? We have continuing education if they went on to other college, if they went into the workforce, if they went into the military, or they had some other activity that they did. First question says, what percent of all these graduates join the military? Well, in order for us to really understand what percentage of each one, we really need to know how many people are in each categorical variable, or each level of the variable. In this case, we have the empty total row and column. These rows specifically are called marginal distributions. So if we look at these rows, I've already got them filled in. We'll look at the different values that we have, and then we can find out percentages based on these numbers. So here we can see that we have in this case, it says what percent of all the graduates join the military. Well, of all of the military group, we have 56 of all 3 graduating classes, 56 people join the military, out of a total for 1415. In order for this, we would simply divide. 56 out of the 1415 actually went into the military overall. So this would be approximately 4%. The first 2 questions, it's easy to see what they're asking. What percent of these students graduated? The first question says, what percent of these graduates? It's really giving you the idea we want to talk about a specific category overall. A two-way table is easy to isolate one categorical variable, which you'll see in a little bit. But you can see in question number 1 and question number 2, it's being very specific to tell you, out of all of the people that were surveyed, how many people fit into this category. Basic probability, or percentages, which is a probability, is simply the portion out of the total. And that's exactly what we did here. 4%, you get 56 divided by 1415, and that'll give you, I think it's like 3.9 something, but it rounds to 4%. Question number 2. What percent of these students graduated in 1970? In this case, it's wanting us to look at simply 1 year of graduation. Rather than an activity, we're going to look at the totals in the columns. So we look at the 1970 column, 601 people out of all the survey was 1415, right? So you would simply say 601 divided by 1415, and that's approximately 42.5%. if we're rounding to the nearest 10th. All right, number 3, it isolates one group out of all of the rest. This question is different than the first 2 because it says what percent of the 1970 graduates. It's telling you, okay, I don't really care about everybody now. I really want you to focus on just one group in the years, and we're going to look at just 1970. So now in my total, the total group I'm interested in is now 601 instead of 1415. So when I do my division to get the percentage, instead of dividing by 1415, we're going to divide by 601. What group are they wanting? Well, which activity are we highlighting? It says, what percent of the 1970 graduates joined the military? Well, in the military, we had 18 out of 601 join the military. And that is approximately 3%. Okay, continuing in the same process, of the students in these surveys who join the military, they're trying to give you different variations on how they can ask. This is really conditional probability or conditional distributions. It's giving you a condition, and in the first one it says what percent of the 1970 graduates join the military. So and the condition was you had to have graduated in 1970 to be even considered. In this case, in number 4, of the students in the surveys who joined the military, my condition which is, in order for me to consider you in this particular question, I have to have joined the military. Okay, from that group, and the total military was 56. Okay, of that group, what percent graduated in 1970? So we look back in 1970, you have 18 out of the 56 graduated in 1970. So in this case, which is a much larger percentage, we have 32.1%. Number 5, it says, what's the marginal distribution of post-graduation activities? Okay, so I've kind of isolated the activity portion. Okay, so it says marginal distribution. In other words, it says, okay, overall, not a specific year. We want to know overall, what is the marginal percentages for this particular column? 905 out of 415, 338 out of 415, and so forth. If we look at this particular column, let me add these back in. If we look at the totals for the margins of each individual activity, okay, because it's asking us about post-graduation activities, not the different years. We'll look at that one in just a minute. So 905 out of 415 continued their education. 338 out of 415, which would have been 23.9%. And you can see the different distributions. I want to call your attention to the bottom percentage. Now this is the total of all the different activities. It's 100.1%. Okay, when you do distributions like this, when you're rounding to a specific number, you are going to see marginal error. This is okay as long as it's 100.1, 100.03, 100, something like that. If it were, let's say, 102, or if it were 97 or 98, then you've probably got too much round-off error. Rule of thumb, when you're rounding, you want to take your decimal at least one place further in all of your data than the number you want to keep. So if I wanted to have one decimal place, for example, what I've written here in my final answer, then I need to round to 2 decimal places when I write this in, if that's what I wanted to keep. Okay, but this amount of round-off error is absolutely fine. If you see things like that, there's nothing to freak out about. Okay, last question. It says, does the study present any evidence that post-graduation plans have changed over this 21-year period? This doesn't include an appropriate graph. I've chosen to create a segmented bar graph. It joins the benefits of a pie chart where you can see portions to the whole, as well as a bar graph where you can see really quick how the different distributions have been set up, and you can compare multiple distributions or multiple variables at the same time. Okay, you can look over here, and I've converted each of the different counts per year. So I've taken each year and I've divided it up into the different percentages for the activities. So let's look at 1959, continuing education, we had 59.16%. 1970, it increased to 64.56%. In 1980, it increased even more, 66.53%. And you can look at the bar chart, and you can see the different distributions. If we look at the blue one, which is pretty obvious, we can look at the employed portion. 30% in 1959, almost 31% went directly into the workforce after high school. In 1970, it dropped almost 8%. And so you can see that as it continues to go on, it continues to drop. Okay, we could look at the purple region, which is your continuing education. It's continuing to increase. And I bet there's some relationship there. I bet more people, as education becomes more and more valuable, it becomes harder and harder to get a job without a really good education, people are going more and more to get education degrees. As you can see, the red, okay, in 1959, extremely small, 3.9%. Okay, in 1970, it had almost tripled, but almost tripled to almost 10%, and it stayed approximately there for there. Okay, you can look, when you look at distributions like this, we want to compare what has changed, what has increased, what has decreased. Okay, there are multiple graphs. You could have used a bar chart here. Simple bar charts. You could have compared different multiple bar charts. You could have written out a pie chart for each one. There's lots of different variations that you could have put into this to compare your graph. I think the segmented bar chart is probably the most concise or compact one that you could have compared multiple distributions with. But if you chose to do something different, it's not wrong. It would be simply a different graph. On the tutorial, I've posted a worksheet which compares eye color and gender. I want you to do basically the same situation that we did here and go through that and see if you can find out, does gender influence your eye color? As you can see here, we can conclude that have graduation plans changed over the past 21 years in this particular period? Yes, it has definitely changed. You can see that the other column has been magnified, or it's doubled or almost tripled. You can see that employment, people are not going to the workforce as quickly. More and more people are going to get their education degrees. You can see the military has dropped down. Okay, make a comparison statement. When you're asked to compare something, you can't just give me, in 1959 it was 59.16%. In 1970, 64.56%. In 1980, 66.53%. I simply made statements about each individual one. I did not make a comparison statement there. Be conscious and be very specific to make a comparison statement. Or you can say in 1980 it was 66.53, so you can look at it's increased 7% from 1959. Make specific statements just like that.